Let's go to page 328. This is lesson 5.5. And this lesson is to use inequalities in a triangle. So in example 1, it says relate side length and angle measure. It says draw an obtuse scaling triangle. So obtuse means you have an angle that's greater than 90 degrees. And scaling means all three sides don't have equal length. So all three sides are different length. Find the largest angle and the longest side and mark them in red. Find the smallest angle and shortest side and mark them in blue. What did you notice? Okay, so what the solution is, notice that the longest side is always facing the largest angle. The smallest angle always faces the shortest side. Okay, so again, smallest angle face the shortest side. The longest side facing the largest angle. Okay, again, so it's a little bit common sense, right? Okay, and so the medium length will face in the medium angle. Okay, so again over here, the longest side and the largest angle are opposite each other. They face each other. The shortest side and the smallest angle are opposite each other. Okay, so the relationship in example 1 are true for all triangles as stated in the two theorems below. This relationship can help you to decide whether a particular arrangement of side lengths and angle measure in a triangle may be possible. Okay, so theorem 5.10. If one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the short side. Okay, so over here, so see this side is longer than that, right? This side is longer than this one. That means this angle would be greater than this one. Okay, because again, this is facing the longer side than this one. Okay, so again, so AB is greater than BC, so AB is greater than BC. Therefore, so measure of angle C is greater than measure of angle A. Okay, and here's a converse. Okay, if one angle of a triangle is larger than another angle, then the side opposite the large angle is longer than opposite side of the small angle. So over here, you have a measure of angle A is greater than measure of angle C. So angle A is greater than angle C. That means this length, so the length BC, okay, so BC is going to be greater than AB. Okay. So let's go to example 2. It's a stage prop. Okay, you are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 27 feet. So that's a picture right over here. Okay, the bottom is 27 feet long. The left slope is about 24 feet. So left slope is about 24 feet. And the right slope is about 20 feet. Okay. Now you are told that one of the angle is about 46 degrees and one is 59. So how do you know which is which? Well, then that's why you use that, right? See, since this side is longer than this side, so the bigger angle, the 59, had to go over here, and the 46, the smaller angle, had to go over here, had to face that. Okay. So what's the angle measure of the peak of the mountain? So what's the angle? Well, remember, 3 angle equal to 180, right? So use 180 minus 46 minus 59 will give you 75. Okay, so again, solution. Draw a diagram, label the side of the length. So draw a diagram, label the side of the length by 27, 24, 20, right? Okay. And the peak angle is opposite the longer side. So here's your peak angle. Okay, so the peak angle is the largest angle. The angle measure sum is 180, so the third angle measurement is 180 minus the sum of these two, or just minus, right? It gives you 75. Okay, so it says you can now label the angle measure in your diagram. Okay, and you double check, right? See the biggest angle facing the longest side. Okay, the smallest angle faces the shortest side, and the medium angle facing the medium length. And so again, it says the greatest angle measure is 75 degrees, so the correct answer is C. Okay, so you can angle, so 75 degrees is the one on the peak. Okay, let's go to theorem 5.10. So you want to prove the theorem 5.10. It says giving BC, so BC is greater than AB. So this length is longer than this side. You want to prove that angle BAC is greater than measured angle C. So again, this is long side, so you want to prove that this angle is bigger than this angle. So what you need to do for this proof, what you need to do is, first you have to draw an isosceles triangle. So whatever this length is, you measure the same length and put a point D. So you can draw a triangle, so that way you got isosceles triangle, okay? And because you have isosceles triangle, so angle 1 will equal to angle 2, okay? So again, locate a point D on BC, okay, locate a point D such that DB equal to BA. So again, so from the point, so all you do is just get this length and put it over here, so you get isosceles triangles. Okay. Then draw AD, so draw this length over here. In the isosceles triangle, okay, in the isosceles triangle ABD, angle 1 is equal to is congruent to angle 2. Okay, because the two angles facing the congruent length are equal, right? Because that's from your isosceles theorem, right? So angle 1 is congruent to angle 2. Okay. Now because angle BAC, so BAC is angle 1 plus angle 3, okay, it follows that BAC is greater than angle 1, right? Because again, so this angle is angle 1 plus angle 3, therefore this angle is greater than 1, right? Because, see over here, right? Because you're adding something, right? Substituting angle 2, measure angle 2 for measure angle 1. So substitute measure angle 1 for angle 2. So you're going to get angle BAC is greater than angle 2, okay? So now, so again, this angle is 1 plus 3. So this angle is going to be greater than 1. But because they are equal, so this angle would be greater than 2. Okay? Now also now you have to use the exterior angle theorem, right? So this exterior angle for this angle and this angle. Okay? So angle 2 is equal to angle 3 plus the angle C. Okay? So again, use your exterior angle. So measure angle 2 equal to measure angle 3 plus measure angle C. And it follows that measure angle 2 is greater than angle C, right? Because again, see over here? Because this is equal to sum of these two, so angle 2 are greater than angle C, okay? And then you substitute, okay? So measure of angle BAC is greater than measure angle 2, okay? Again, so this angle is greater than angle 2, and therefore, and so again, see over here? So this angle over here, BAC, is greater than 1, and 1 and 2 are equal, so therefore BAC is greater than 2, and 2 is greater than this, therefore the BAC is greater than angle C, right? So again, finally, because angle BAC, so angle BAC is greater than angle 2, and measure of angle 2 is greater than measure of angle C, so you can conclude that angle BAC is greater than measure angle C, okay? So you can go summarize again. So BAC is this over here, and again you can see it obviously, right? So this angle is greater than 1 because 1 plus 3 is greater than 1, right? And 1 and 2 are equal, so you can substitute. So 1 plus 3 is equal to greater than 2, and 2 is equal to 3 plus that. So again, this angle is bigger than that, which is bigger than that, and which is bigger than that. Therefore, this angle is bigger than that, okay? So that's kind of the proof. Again, this kind of paragraph proof that you kind of have to kind of think it through, okay? Okay, let's go to the next one. Okay, the triangle inequality. Not every group of 3 segments can be used to form a triangle. Okay? The length of the segment must fit a certain relationship. For example, okay, 3 attempt at triangle construction for sides with given length are shown below. Only the first set of length of the side length form a triangle. Okay? So again, if you draw the triangle, if you got 2, 4, and 5, you're able to form a triangle. Okay? If you have 2, 2, and 5, see what happens? These two sides is not enough to form a triangle. If you try to swing it to meet, then they're going to fall short. Okay? And if they're equal, 2, 3, and 5, what happens when they fall? They're going to meet right over here. Okay? So again, you're not going to get a triangle. Okay? So if you start with the longer side and attach the other two sides at the endpoints, you can see that the other two sides are not long enough to form a triangle in the second and the third figure. This leads to the triangle inequality theorem. So what this theorem says is that, okay, the sum of the length of any two sides of a triangle is greater than the length of the third side. Okay? So again, if you have a triangle, then the two sides must be add up greater than the other side. Okay? If it's not, then you're going to end up with this situation or this situation. So again, the two any two sides have to end up longer than the third side. Okay? If not, you're going to fall short or become exactly, then you're going to get a line on a line. Okay? Okay, so again, so AB, so AB plus BC, so AB plus BC have to be greater than AC, and same thing. So any two sides have to be greater than the third side. Okay, when you add any two sides, it has to be greater than the third side, or else you're not going to be able to have a triangle. Okay, if you don't have the situation, you can end up something like this. Then you won't have a triangle. Okay, so again, any two sides, you add any two sides, it has to be longer than the third side. Okay, so let's go to example 3. Find possible side length. Okay, a triangle has one side length of 12, another of 8. Describe possible length of the third side. Okay, okay, solution. So it says let x represent the length of the third side. Draw a diagram to help visualize the small and a large value of x. Use the triangle inequality theorem to write and solve the inequalities. Okay, so small value of x. Okay, so there are different cases. Okay, one case is that x is not the largest. Okay, so 12 is the largest number. Okay, so in this case, x plus 8 had to be greater than 12. Right? Again, so there are two cases. X is not the biggest, so 12 will be the longest side. Okay, another case is x is the longest side. Okay, so two different cases. So small value of x, so you're going to have x plus 8 had to be greater than 12. So x had to be greater than 4. Okay? Now, if x is the longest, then 12 plus 8 had to be greater than x, right? So 8 plus 12 is greater than x. So 20 had to be greater than x. So x had to be less than 12. Okay? So the length of the third side must be greater than 4, right? Greater than 4, and less than 20. Okay, in order to have a triangle.